Okay, so DeepSeek, the folks behind that DeepSeek V3 model that kind of shook things up a bit,
Yeah.
well, they're back.
Oh, really?
Yeah, with a new paper.
What are they looking at this time?
This time they're really taking aim at boosting those reasoning capabilities in large language models.
Interesting. So like reasoning and logic.
Yeah.
That's a big one.
And this paper details their new DeepSeek R1 model, and it's got everyone talking.
Yeah, I can imagine. Reasoning is sort of the holy grail of LLMs.
Well, and what's really fascinating about this paper is their approach to training.
Okay, how are they approaching it?
They're really pushing those boundaries with reinforcement learning.
Interesting. So are they saying you can develop good reasoning skills without relying so heavily on supervised fine-tuning?
Yeah, that's what they're demonstrating, and I think is pretty interesting.
Yeah.
They've developed two models, DeepSeek R10 and DeepSeek R1.
Okay. Two new models.
And DeepSeek R10 is the real groundbreaking one because it's trained entirely using reinforcement learning.
Wow, so no supervised fine-tuning at all.
No initial supervised fine-tuning.
That's a big departure from how most LLMs are trained.
It is. Most of them rely so heavily on those massive data sets for initial training.
Right. So how did they manage this? What was their starting point?
Well, they started with their base model, DeepSeek V3 base.
Okay. Makes sense.
And then they applied a reinforcement learning algorithm. Have you heard of GRPO?
GRPO, yeah. Group Relative Policy Optimization. I've seen that in a few papers.
Yeah. What do you remember about it?
Well, it's known for its efficiency.
Right.
It doesn't need that separate critic model that you see in a lot of traditional reinforcement learning setups.
Right.
And it estimates the baseline from group scores, which just simplifies the whole training process.
Yeah.
Computationally less demanding.
And they're really getting more for their computational buck.
Right. Exactly.
Yeah. And you need that efficiency when you're training these models to solve these complex problems.
Yeah, absolutely. Especially reasoning problems. It can get pretty computationally intensive.
So how did they guide DeepSeek R10 to develop those reasoning skills? Like, how does that training actually work?
Well, they had a specific template
Okay.
that they used during training, and it encouraged the model to, I don't know a better way to say this, but like show its work.
I love that.
Yeah, it kind of nudged the model to first generate that step-by-step reasoning process.
Okay.
Essentially a chain of thought before getting to that final answer.
So it's not just give me the answer, it's show me how you got there.
Exactly. And this transparency is super important because you want to understand how the model's learning and making decisions.
Right. You want to know the process is sound and it's logical.
Exactly.
Well, we all know that reinforcement learning relies heavily on rewards.
Right.
To guide that learning process.
Yeah.
What kind of reward system were they using for DeepSeek R10?
Well, they kept it pretty straightforward. Just focused on two main things: accuracy and format.
Makes sense.
The model got rewards for giving the right answer, obviously.
Right.
Pretty standard.
Yeah.
But they also incorporated a reward for sticking to that specified output format.
Points for neatness and organization.
Yeah, you could say that. That format reward just helps make sure that the model's output is, clear and consistent, easy to interpret.
If it's all over the place, it's really hard to follow.
Right. Especially with those complex reasoning tasks, you need to be able to follow that chain of thought to understand how it's coming to those conclusions.
So how did DeepSeek R10 actually perform after all that training? Did this show your work approach actually lead to better reasoning?
Yeah, the results were impressive.
So it's not just a theoretical concept. This thing can actually perform in the real world.
Oh, yeah, absolutely. One of the most striking things they observed during training was how DeepSeek R10's thinking time actually increased as it went on.
Hold on, you're saying it started taking longer to solve problems?
Yeah.
Isn't that usually a bad sign?
Not in this case.
Okay.
It actually learned to allocate more time and computational resources to those harder problems.
So like a student realizing they need to spend more time studying for a tough exam.
Exactly. It's like it was adapting and understanding the task at hand, getting deeper into it.
So it wasn't just cranking through problems at the same speed, it was actually like learning to pace itself.
Yeah.
Based on the complexity.
Right. And this adaptive behavior was also evident in that aha moment we talked about earlier.
Yeah.
You remember where DeepSeek R10 was working on that complex math problem, and it seemed to realize its initial approach was flawed.
Yeah, it almost felt like the model was having a metacognitive experience.
Yeah.
Like questioning its own assumptions and strategies.
Yeah. It's really fascinating how reinforcement learning can lead to these unexpected behaviors in these AI systems.
So DeepSeek R10 wasn't just following some predetermined set of rules. It was actively learning and adapting based on its experience.
Right.
Okay, so we've got this model that's trained entirely on reinforcement learning, showing signs of adaptive behavior,
Mm.
even having aha moments. But you mentioned there were two models in this paper, right?
Right.
What about DeepSeek R1? How does it differ from DeepSeek R10?
Well, DeepSeek R1, it builds on DeepSeek R10.
Okay.
But with a few key refinements. You know how we talked about how DeepSeek R10 would sometimes have some issues with readability and language mixing?
Yeah, it felt like it was still figuring out how to communicate its process clearly.
Right. So with DeepSeek R1, they wanted to fix those limitations.
Okay, how'd they go about it?
So they started by introducing this cold start phase,
Okay.
where they fine-tuned the base model with a small set of human-curated data.
Why the sudden shift to supervised learning? I thought they were all about the power of just reinforcement learning.
It's not a complete shift. It's more like a strategic addition. These cold start examples were specifically chosen to kind of address those readability issues they saw in DeepSeek R10.
So they gave it a foundation in generating those clear, well-structured reasoning processes.
Yeah, like giving a student a really well-written essay to learn from.
So it's like, okay, you've got the raw reasoning power down, now let's refine your communication skills.
Exactly. And then after that initial fine-tuning, they went back to reinforcement learning,
But
but they tweaked the reward system a little bit.
how so?
Well, in addition to accuracy and format, they introduced rewards for helpfulness and harmlessness.
Interesting. It seems like they're really trying to instill these models with a sense of responsibility,
Yeah.
moving beyond just accuracy to think about those broader ethical implications.
It's an important step, especially as these models are getting more powerful, you know?
Right.
The helpfulness reward encouraged the model to give responses that were actually useful and relevant to the user.
It's not just about giving the right answer, it's about understanding the user's intent and providing value.
Right. And then the harmlessness reward, that's about making sure the model isn't, generating harmful or misleading content.
Right. Mitigating those potential risks and biases, making sure that the model's outputs align with our values
Exactly. They're basically building in those guardrails.
to prevent it from going off the rails.
Yeah, it's like they're acknowledging that even in AI with great power comes great responsibility.
So did these refinements actually pay off?
Yeah.
How does DeepSeek R1 stack up against its predecessor and other leading LLMs in terms of performance?
Well, let's get down to it. How does DeepSeek R1 actually perform? They've made some bold claims. Can it back it up with hard results?
Yeah, they've got a lot to prove.
The short answer is yes. And then some DeepSeek R1, it goes head to head with some of the biggest names out there, including OpenAI's models, and really hold its own.
Okay, give me the highlights. What are we talking about here?
Well, let's start with A, that notoriously challenging math competition for high school students.
Oh yeah, that's a tough one.
DeepSeek R1 achieved a pass at one score of 79.8%, which is exceptional.
That's impressive.
What's even more remarkable is it actually outperformed OpenAI's O1-1217 on this one.
Wow, beating OpenAI at their own game.
Yeah.
That's a statement, but was that a fluke, or can it consistently hold its own against the top models?
It's definitely not a fluke on Math 500, another challenging math benchmark. DeepSeek R1 scored 97.3%, performing on par with O1-1217 and significantly outperforming other models.
So it's a math whiz, but AI models often struggle when it comes to coding, which requires a different kind of logical thinking.
Yeah.
Yeah. How did DeepSeek R1 fare in that arena?
DeepSeek R1 didn't just pass the coding test, it aced it on Codeforces, that competitive coding platform. It achieved a rating of 2029, outperforming over 96% of human participants.
It's writing code that's better than the vast majority of human programmers.
It is.
That's a bit intimidating, to be honest.
Yeah.
But it also just really speaks volumes about its ability to grasp complex logic
Right.
and translate into functional code. It's not just solving textbook problems.
Right.
It's creating real-world solutions.
Exactly. And on LiveCodeBench, a benchmark focused on practical coding skills. DeepSeek R1 got a pass at one score of 65.9%,
Okay.
surpassing OpenAI's O1 Mini, which scored 53.8%.
So it can actually put those skills into practice.
It can.
So we've established that it's a mathlete and a coding champ,
Yeah.
but can it handle more general knowledge and reasoning tasks? The real world isn't all equations and algorithms.
Right. That's where things get even more interesting. DeepSeek R1, it also excels in tasks that require a broader understanding of the world.
Okay, like what?
On MMLU, that massive multitask language understanding benchmark, it scored an impressive 90.8%, outperforming many other well-known models.
So it's not just a one-trick pony.
Yeah.
It seems like DeepSeek has managed to create a model that's both specialized and versatile, capable of tackling a wide range of tasks that require different types of reasoning and knowledge.
That's a great way to put it. They've struck a balance between depth and breadth, showing that a model can excel in specific domains like math and coding, while also having that broad base of general knowledge. But as with any AI model, DeepSeek R1 isn't perfect.
Yeah, no model is going to be the ultimate AI.
Right.
What are some of those limitations that they highlighted?
One area they pointed out is general capabilities, particularly in tasks that require more nuanced language understanding. While DeepSeek R1 shines in reasoning-heavy tasks, it still lags behind its predecessor, DeepSeek V3, in areas like multi-turn conversations and those more complex role-playing scenarios.
So it's a trade-off. They've prioritized those reasoning abilities, but at the expense of some of the more social and interactive aspects of language.
Right, it's like they've created a brilliant logician, but not necessarily a smooth talker.
Okay, I like that analogy.
They also acknowledge that they need to do a better job of handling languages beyond Chinese and English.
Right.
Right now, the model is primarily optimized for those two languages, which could limit its global reach and applicability.
Yeah, expanding language support will definitely be crucial if they want it to be a truly universal AI tool. Any other limitations worth mentioning?
They also found that DeepSeek R1 can be pretty sensitive to how a question is phrased. Even small changes in wording can really impact its performance, suggesting that it might not always be robust enough to handle the ambiguity and variability of natural language.
Still a bit literal-minded.
Yeah.
Needs to develop a better understanding of those subtle nuances of language to
Yeah.
really excel.
Right. And finally, they point out that DeepSeek R1 hasn't shown as much improvement over DeepSeek V3 in software engineering tasks.
So while it can write impressive code, it might not be ready to replace human software engineers just yet.
Probably not yet. But even with these limitations, DeepSeek R1 represents a significant step forward in AI development. It challenged the notion that only those massive models with billions of parameters can achieve groundbreaking results.
It's like they're saying size isn't everything.
Right.
They've shown that with clever training techniques and a focus on efficiency, you can get remarkable performance even with a relatively smaller model.
And that's a really exciting prospect for the future of AI. It opens up the possibility for smaller teams, even individuals, to contribute to the field without needing access to vast computational resources.
It could democratize AI development and lead to a more diverse and innovative landscape.
Exactly. It's a reminder that innovation isn't always about brute force. Sometimes it's about finding elegant solutions that achieve more with less.
And DeepSeek's work with DeepSeek R1 is a great example of that philosophy. They've shown that you can push the boundaries of AI without breaking the bank or relying on the biggest, most powerful models.
Right.
This has been a fascinating deep dive into the world of DeepSeek R1. We've covered everything from the technical nuts and bolts to the broader implications for the future of AI. Any final thoughts to leave our listeners pondering?
I think DeepSeek R1's success with distillation, where they transfer those reasoning capabilities to smaller models, is particularly intriguing. It suggests that we might not always need to build ever larger models to achieve higher levels of intelligence. Perhaps the key lies in refining and transferring knowledge,
Right.
finding ways to pack more intelligence into smaller, more efficient packages.
It's a reminder that the pursuit of artificial intelligence is as much about understanding the principles of intelligence as it is about building bigger and better machines. And on that note, we'll wrap up our deep dive into the DeepSeek R1 paper. We encourage you to explore the paper yourself and continue to engage with the ever-evolving world of AI. Till next time, happy learning.